This is the first section from the Jeopardy review, and it covers direct comparison test. So as we look at this question and decide whether this converges or diverges, we need something to compare it to. This one, it would make the most sense to compare to 1 over n squared. If we just take away the 5, we're left with 1 over n squared. We know that 1 over n squared converges. It's a p-series where the power is greater than 1. Now if it converges, we want to be able to prove that it is the bigger one of the two, because if the bigger one converges, then the smaller one also converges. Okay, as we set up this inequality, we can cross multiply, and this does in fact prove to be true. Adding 5 is going to make it bigger, so that works, and that proves that this original equation converges. Question number 2, converge or diverge? This time it'd make most sense to compare this to 1 over 4 to the n, which is the same thing as 1/4 to the n. That's a geometric series that converges because the r is less than 1, So again, we hope that it is the bigger one, because if the bigger one converges, then the smaller one also converges. So we set up this inequality to test it out, cross multiply, and it does in fact prove true. Adding 3 makes it greater, so this means that our answer is converge. Number 3, we have 5 over 3n minus 4. Okay, I'm going to just remove the minus 4 and look at 5 over 3n. It's possible you can remove the 5 or the 3 if you want to, and this will still work, but I usually find it simpler to leave it if I can. So this is a p-series, even with the 5/3, that doesn't change anything. It's a p-series where the power is 1, which means it diverges. Now if it's diverging, we hope that it's the smaller one, because if the smaller one diverges, then the bigger one has to diverge as well. So we test this with the inequality, cross multiply, and it is true. Subtracting 4 will make that smaller, so that proves that the original diverges. Okay, this next one, what we really have on the bottom is n squared. So I'm actually going to keep the 6 and do 6 over n squared. If you need to distribute this, you can. It'd be n squared plus 2n. And I'm going to compare it with 6 over n squared. Now, we hope that this converges, this does converge, because it's a p-series where the power is greater than 1. So we hope that it is the bigger one of the two. So we do 6 over n squared greater than or equal to 6 over n squared plus 2n. So I went ahead and distributed that n times n plus 2. Then we cross multiply, and this again proves true. So it works and is confirmed that both of these series converge. Okay, this is the last one for direct comparison. If you go ahead and distribute this, it's n squared minus 4n, and the square root of n squared is really just n. So it's 4 over n that I'm going to compare it to, and that diverges. Okay, so notice in general it's helpful to leave the coefficients if possible. So 4 over n diverges. Now if it diverges, our hope is that it is the smaller one, because if it's the smaller one, then this should hold true. Okay, so we're hoping this is true. We cross multiplied, and this is in fact true. If it's not easy for you to see that, then you can plug this in y1 and this in y2 and test it out. But if you think about it this way, the square root of n squared is just n, and then this part's being subtracted, so that's going to make it smaller when you subtract. So this proves true, which means the answer is diverge. So now switching gears, we're going to look at the limit comparison test. With the limit comparison test, you want to take the most powerful term on the top and the most powerful term on the bottom. So we'll do n squared over n cubed, which reduces to 1 over n. 1 over n is a p-series that diverges because the power is 1. And with the limit comparison test, we want to do the limit as n approaches infinity of one of these equations, doesn't matter which one goes on top, over the other equation. And then you multiply by the reciprocal because we're dividing fractions. And in fact, I'm going to skip to this step every time from here on out, just to save some time and some space. So when we multiply these together, we get 3n cubed minus 5n over 2n cubed minus 7n. And as we take the limit as n goes to infinity, we see that the powers are the same. They're both cubed. That means the coefficients are the answer. So 3/2 is our answer. And with the limit comparison test, the rule is, as long as your answer is finite and positive, basically you don't want it to be 0 and you don't want it to be infinity. As long as it's finite and positive, it proves they both do the same thing. So this answer right here proves that they both diverge. Okay, next question. Again, we want to take the most powerful term on the top and the most powerful term on the bottom. N over n cubed. That reduces to 1 over n squared, which converges. It's a p-series with a power greater than 1. So we do the limit as n approaches infinity. Remember, we're actually dividing these fractions, but I'm skipping to the step where we multiply by the reciprocal. And that gives us n cubed on top over 5n cubed plus 6n squared minus 4. So the powers again are the same. They're both cubes, so you just use the coefficients, which would be 1 over 5. As long as the answer is finite and positive, they both do the same thing, so they both converge. Okay, for this one, the most powerful term is the 4th root of n to the 4th, which is really just n. So when we look at that, it diverges because it's p-series with a power of 1. We do the limit as n approaches infinity of 2 over the 4th root of n to the 4th plus 3n times n over 1. 2n over the 4th root of n to the 4th plus 3n. And the powers are the same because you treat this as the 4th root of n to the 4th, which is n. So the powers are the same on top and bottom. So use the coefficients, which would be 2 over 1. That answer is finite and positive. So that proves they both do the same thing. So they both diverge. Okay, this one, go ahead and distribute that. It's n squared. So you really have the square root of n squared. So again, we're comparing it with 1 over n, which diverges. We do the limit as n approaches infinity. And we're actually dividing one fraction by the other. But again, to save time, I'm going to go to the multiply by the reciprocal step. And again, they have the same power. If I go and distribute the bottom, this part right here, it gives me n squared plus n. And the square root of n squared plus n is just n. So that's n to the first, n to the first. So the powers are the same, meaning we use the coefficients, which are all 1. This answer is finite and positive, which proves they both do the same thing. So they both diverge. Last question for limit comparison. Take the most powerful term on the top and the most powerful term on the bottom. Gives us n squared over n to the 5th, which is 1 over n cubed. That converges because it's a p-series with the power greater than 1. We do the limit as n approaches infinity of one of those fractions over the other. So I'm going to skip to the multiply by the reciprocal part. Gives us 4n to the 5th minus 9n to the 4th over n to the 5th plus 4n squared. Now the powers are the same on the top and the bottom, so we need to use the coefficients. That's 4 over 1, which is 4. As long as the answer is finite and positive, they both do the same thing, so they both converge. Okay, I think we're going to save this for part 2 of the video. We're switching to the ratio and root test, so we will do that on part 2.